I explain, but understand every conversion, displacement to velocity time, every conversion, you are learning something, right? So still you didn't completely learn important concepts when converting displacement time graphs into velocity time graph. So therefore my advice is every graph I take time and explain, get the maximum knowledge from each graph, because some important points are there I can't give directly as theories. So therefore by doing each conversion only I can explain this is what happens here. If the graph is like this is the meaning of that, but you should quickly catch them, right? We'll do it. Okay, graph number 4. Graph number 4. Next one. If you can do it, you keep on doing, right? So always try by yourself on. Because when I explain, it seems you understand, but when you do it by yourself own, then only you will understand some troubles. This type of graphs. But when we consider this final point, this final point is not horizontal, understand? This point, the point where the graph ends, it's not horizontal. So still there is some kind of inclination, okay? Yes. Now in that case, just think about what's happening. Now what's happening to the gradient? Displacement time graph, gradient represents velocity. Displacement time graph, gradient represents velocity. What can you say about the variation of velocity through the time? Just check the angle. Angle is obtuse. Obtuse angle. We know angle is obtuse. Obtuse angle. What will happen with the obtuse angle? That obtuse angle is increasing. Am I correct? Obtuse angle is increasing with the time. Obtuse angle is increasing. Then what can you say about the gradient? Obtuse angle increases, that means negative gradient decreases. Negative gradient decreases in the sense negative velocity decreases. Am I correct? Negative velocity decreases. Negative velocity decreases. Okay. Now raise your hands. How many of you understood this graph represents negative velocity decreases? Negative velocity decreases. How many of you understood? Because I have explained all these things. I took time and explained. Okay, now we'll convert. Now, if you can do it, you continuously do graph number 4, 5, 6, 7, 8, 9, 20. Continuously, you guys keep on doing. Don't wait until I explain something. Right? Okay. Then if I draw the VT graph. If I draw the VT graph. Now, negative velocity decreases. And also we want to check when the time is 0, I want to check the gradient. When the time is simple t, when the time is simple t, I want to check the gradient, right? When the time is 0, if I draw a tangent line, when the time is 0, if I draw the tangent line, when the time is 0, if I draw the tangent line, if I draw it, when the time is 0, if I draw a tangent line, there's an obtuse angle. right? When the time is simple t, if I draw a tangent line, when the time is simple t, if I draw a tangent line to that point, that tangent line makes an obtuse angle. When the time is 0, if I draw a tangent line, that tangent line makes an obtuse angle. When t equals 0, I say obtuse angle is theta 1. This why I deeply explain all these points, because in MCQs that's how they ask, right? I can teach you this thing, but I say that no, now linear motions, vertical motion under gravity, projectile motion, even you don't understand them, that's completely all right, but you should have 100% understanding in motion graphs, because not only graphs related to motion section throughout your this physics unit, there are different types of graphs that you will learn. So that's why I deeply explain, because it's important. It's very, very important. Okay. When the time is simple t, I say angle is theta 2, theta 2. And then we know that comparing with theta 1, theta 2 is larger. Obtuse angle. Theta 1, theta 2 both are obtuse angles. Theta 1 and theta 2 both are obtuse angles. And we know that theta 2 is larger than theta 1. Right? So they are obtuse angle means they are velocities, negative velocities. When t equals 0, already object is having a negative velocity, right? When t equals 0, object has a negative velocity. What happened to negative velocity? Negative velocity gradually decreases. When the time is simple t, still object has a negative velocity, but that negative velocity is lesser than initial negative velocity. Okay. So negative velocity v2 when the time is simple t is lesser than negative velocity when the time is simple t1. So then negative velocity, how do we represent negative velocity? Below the time axis, negative velocity decreases. Negative velocity decreases. Is the graph. When t equals 0, negative velocity is larger. When t equals 0, negative velocity is larger. When t equals simple t, there's a negative velocity, but somewhat smaller. Now raise your hands. Did you understand? Did you understand? If you understood this graph, raise your hands. You understood, raise your hands. Now, in addition to this graph, the problem is now, last day, I think I gave a big explanation. A negative velocity decreases. We can draw 3 different types of velocity time graph to represent negative velocity decreases. Negative velocity decreases under constant rate. Negative velocity decreases under increasing rate. Negative velocity decreases under decreasing rate. So therefore, now one can draw. Now the basic idea is negative velocity decreases. Then one can draw a graph like this, linear graph. If one can draw a graph like this, this graph is also basically what's happening. Negative velocity decreases. If one can draw a graph like this, no matter these 3 graphs are valid. Okay. No matter you are going with this graph or this graph or this graph, both graphs represent negative velocity decreases. But understand these 3 graphs have 3 different meanings. This one also shows negative velocity decreases. This one also negative velocity decreases, negative velocity decreases. But the thing is, negative velocity decreasing under increasing rate. Negative velocity decreasing under decreasing rate. Negative velocity decreases under constant rate. So you don't bother with that. If you draw any of these 3 graphs, that's correct. That's it. Okay. But upcoming graphs, look here, upcoming graphs, I always know this one. If I want to represent negative velocity decreases, In upcoming graphs, I draw the straight line graphs. Okay. If not, you can use any of the graphs, but upcoming graphs, I consider negative velocity decreasing means always straight line graph. But other two possibilities are there. Okay. Next one. Next one. Graph number 5. Graph number 5. Keep drawing. Graph number 5. Displacement time graph. Yes. In this case, now what can you say about the velocity? Check the gradient. Gradient obtuse angle with the time obtuse angle decreases. Obtuse angle decreases in the sense negative gradient increases. Negative velocity increases. When t equals 0, if I draw a tangent line, when t equals 0, if I draw a tangent line, the tangent line is horizontal. Tangent line is horizontal. When t equals 0, we can say that velocity 0. Okay. When the time is simple t, if I draw a tangent line, there is a tangent line makes an obtuse angle. So therefore, there is a velocity, there is a negative velocity when the time is simple t. When the time is simple t, there is a negative velocity. Negative velocity increases from 0 to certain value. Negative velocity increases from 0 to certain value. Negative velocity increases from 0 to certain value. Okay. As I mentioned before, normally this is the graph. In addition to this graph, if one student can draw this graph. If not, this graph. I hope you understand. Graph number 6. Graph number 6. Okay, I erase this one. Graph number 6. Displacement time graph. In this type of cases, what you do now, you have to divide the graph into 2 subsections. Now, you need to argue what's happening in each section by dividing the entire graph into 2 subsections. So I say this first section, if not first part 1, the second part is part 2. This is part 1. This is my part 2. Forget about the part 2. If you're arguing about what's happening in the first part, what's happening in the first part? Angle is acute from initial point to the point where first graph ends. Just forget about the second graph. Think about initial point to the point where first graph ends. This is the point where first graph ends. This is the point where first graph starts. Then just think about what's happening to the gradient. First of all, think about the angle, acute angle. Okay, tell me, reply, put in the chat box what's happening. What's happened to the velocity? Negative velocity decreases, negative velocity increases. Likewise, everyone put in the chat box what's happening in the first part. What's happening in the first part? Reply quickly. What's happening in the first part? Reply quickly. Everyone quickly put it. Now very carefully think whether you want to think whether it's acute angle or obtuse angle. Then if it is acute angle, if acute angle increases, positive velocity increases. If acute angle decreases, positive velocity decreases. If the angle is obtuse, if obtuse angle increases, negative velocity decreases. If obtuse angle decreases, negative velocity increases. That's the logic. That's the logic. Right? That's the logic. So therefore, very carefully apply the logic. That's important. Yes. In this case, first graph, acute angle. What's happening? Acute angle. This acute angle is decreasing. Acute angle is decreasing with the time. With the time, acute angle is decreasing. Just check. With the time, acute angle is decreasing. If acute angle is decreasing in the first part, what can you say about the velocity? Acute angle decreases means positive gradient decreases, therefore positive velocity decreases. Positive velocity decreases. And just think about when t equals 0. When t equals 0, if you draw a tangent line, when t equals 0, if you draw a tangent line, when t equals 0, tangent line makes an acute angle. When t equals 0, tangent line makes an acute angle. So therefore, initially, when t equals 0, there is a positive velocity. When t equals 0, there is a positive velocity. When t equals 0, right? So there's a positive velocity, right? Velocity is positive. Then what's happening? Positive velocity is decreasing. What can you say about the velocity at the end point of the first graph? What can you say about the velocity at the end point of the first graph? Just draw tangent line. Just draw tangent line. If I say this time is simple t1, this time is simple t1, this time is simple t2. When the time is simple t1, just draw tangent line. When the time is simple t1, draw tangent line. If I draw the tangent line, we get tangent line as horizontal. Then I can say that with horizontal tangent line means velocity is 0. When the time is simple t1, velocity is 0. That's it. First of all, we'll draw that graph. If I draw that graph, if I draw it, initially there's a positive velocity. Initially there's a positive velocity somewhere here. When the time is simple t1, the time is simple t1, velocity is 0. If I draw the graph, is the graph. There's a graph, right? Now what's happening? But I told you that always there are three possibilities. If one student draws a straight line between these 2 points, it is also accepted. But mostly everyone draw straight line graphs. Mostly VT graph means everyone draws straight line graphs. When one student, rather than drawing a straight line graph, if that student has drawn blue color or red color graphs also accepted. But I told you that hereafter I don't draw this blue color or red color curved graphs. I don't do it. I don't draw it. But you should think that, you should understand that even some student drawing that way, that is also correct. I think you are I'm saying. I hope that. Okay. And then check about second part. When I consider part number 2, this first part. If I do the part number 4, part 2, when the time is simple t, because first point of the second graph is the last point of the first graph. The first point of the second graph is the last point of the first graph. When the time is simple t1, second graph starts the motion from rest. Then what's happening to the angle? Just check the angle. If you check the angle, angle is obtuse. Angle is obtuse. And what's happening to the obtuse angle? Obtuse angle. What's happening to the obtuse angle? Obtuse angle decreasing. Obtuse angle decreasing means, understand, negative velocity increasing. Negative velocity increasing. Second one, what's happening? Negative velocity increasing. From zero velocity, negative velocity increasing. You got it? Negative velocity increasing. Am I correct? Did you understand? So raise your hands. How many of you understood this graph answer? Did you understand this graph number 6? Raise your hands. If you understood, raise your hands. Yes, okay. Then graph number 7. Graph number 7. Graph number 7. Now hereafter, my advice is you also follow. Don't draw these curved graphs. My advice. Yeah, it's correct. That's correct. But my advice is don't draw these curved graphs. We'll always draw these straight line graphs, because there's a reason, but I don't tell right now. Okay. All are possible, but my advice is hereafter you also draw only the straight line graphs for VT graphs. When converting ST to VT, always try to make sure your VT graph is straight line graphs. Understand? That's my advice. It's up to you. You can draw any of them. It's nothing bad, nothing wrong. But I advise you to draw straight line graphs. Graph number. Next one is graph number 7, 8, 7th one. Graph number 7. Graph number 7. Displacement. Graph number 7. So you guys keep on drawing. I think now you guys understand what's happening here. You keep on drawing. Raise your hands. How many of you finished seventh one? Seventh one done. Hands up. Seventh one finished so far. Raise your hands. How many of you finished seventh one? There are three. All of you finished seventh one. Eighth one finished, hands up. Eighth one finished. Ninth one finished, hands up. 9 also done. 10th one. Keep on. Okay, very good. You guys keep on doing. Don't wait until I do. Okay, I do because everyone should be understand what's happening here. But you keep on, you finish. You quickly finish it. Now here what's happening here. Now, when t equals 0, there's an acute angle. When t equals 0, there's an acute angle. When the time is simple t1, when the time is simple t1, if I draw a tangent line, when the time is simple t1, velocity is 0. Okay. When the time is simple t2, if I draw a tangent line is obtuse angle. That means negative velocity. When the time is 0, acute angle, therefore positive velocity initially. When the time is simple t1, 0 velocity. When the time is simple t2, negative velocity. If I draw the graph, just think about if I divide into two subsections. First part, part number 2. What's happening in the first part? Just think about the angle, acute angle. That acute angle is decreasing. Very similar to this graph. Acute angle is decreasing, therefore positive velocity decreasing. Positive velocity decreasing. Then if I draw the first part, positive velocity decreasing, when t equals 0, there is a certain positive velocity. When the time is simple t1, velocity is 0, positive velocity is decreasing. Positive velocity decreasing. Okay. Right? And look here now. I will tell you, look here. Now look here, stop doing and look here. Now some students, if you have some confusion regarding if there are 2-3 parts in the graph, if you have 2-3 parts in a graph, first of all, divide into sections. Now as I divided section 1, section 2, divide into sections. Now I think most of you can draw the first part. The problem is how to do the second part. The point where you finish first graph, it's not necessary step. But if you feel some kind of confusion, the point where you finish first graph, this is the point where I finish my first graph. Again, think as the origin. Do you understand? The point where you finish your first graph, think as your origin and just draw two axes, y and x. This is your origin. Just think about this is your y axis. It's not compulsory. Think this as your y axis. Think this as your x axis. Okay, think the point where you stop the first graph, think that is the origin and draw y and x axis. Above positive, below negative. From this origin to right positive, from this origin to left negative. Again, start drawing this graph. What's happening? What's happening? This graph, what's happening? Obtuse angle constant. Obtuse angle constant. Right? Obtuse angle constant. Okay. Obtuse angle constant means negative velocity constant. Negative velocity constant. Negative velocity constant. How do you draw negative velocity constant? From the point now here first graph finishes at this point. Then it's a new graph. Think about graph part 2 is a new graph. Then the graph is, forget about this part. Follow this part. This is your y-axis velocity. This is your x-axis time. It's a new graph. Negative velocity constant. How do you draw negative velocity constant graph? How do you draw negative velocity constant graph? Like this. That's it. Okay. I hope you understand. Okay, now there can be some, now in velocity time graph, understand, in VT graphs, there can be discontinuities. It's not always compulsory to start second part of the graph from the point where first graph finished in velocity time graph. Understand, velocity time graphs, there can be discontinuities. That means first graph has finished this point. We started to draw the second graph from this point. There is some discontinuity between the pointer where first graph finished and the point where second graph started. That's okay. Velocity time graph, there can be plenty of discontinuities. Okay. I hope you understand. If you have any, tell me. Then graph number 8. Graph number 8. Graph number 8. 8-1. Now graph number 8 is something like this. Graph number 8. Now there are two graphs in graph number 8. So don't think it's one curve, right? Don't think it's a curve. Don't think it's a curve. Give me a second. You don't wait until I do, you keep on do. This is our graph number 8. Now, this graph contains two sections. The point where first graph finishes, that's a curvy part. So therefore, there are two graphs. Part number 1, part number 2. Now, part number 1, acute angle constant. Part number 1, you can understand. Just think about the angle, acute angle from here to here, 0 to T1 is T2. Acute angle constant. Acute angle. Acute angle. I think you guys can understand. Many times I explain these things. Just go and check the recordings. Acute angle constant means positive velocity constant. When t equals 0, velocity is 0. When t equals 0, when t equals 0, my bad. When t equals 0, that's an acute angle. If I draw a tangent line when t equals 0, that's a positive velocity. When t equals simple t also, because acute angle is constant, positive velocity constant. Velocity is same plus v. The time is simple t also. Okay, then second one. In second graph, what can you say about the velocity? Acute angle is increasing. Acute angle is increasing. Acute angle is increasing. So therefore, positive velocity increasing. Positive velocity constant in first part. Second part, positive velocity increasing. In that case, how would you draw that? Positive velocity constant in first part. Positive velocity constant. Positive velocity constant. The second part, positive velocity increases. Positive velocity increases. Positive velocity. Above the time axis, velocity is positive. About the time axis, velocity is positive. Positive velocity is increasing. Positive velocity increasing. That's it. Then graph number 9. 9, 10, 11, 12. Graph number 9. It contains 3 sections. Graph number 9 contains 3 sections. Now think this last point is horizontal. Now we'll assume, okay, now even in that diagram in the tutorial, so it's okay. Now let's assume this last point is horizontal, okay? Let's assume that way. If you draw the graph, not considering last, if you draw a tangent line to the last point, if you drew, there's an angle, that's okay. Now I draw the graph considering if I draw a tangent to the last point, that's horizontal, okay? In that way I draw it, okay? Now I can divide this graph into 3 sections. 3 sections. Now, first section, displacement is 0. If displacement is 0 throughout the time, velocity is 0. Velocity is 0. Second one, acute angle constant. Acute angle constant means positive velocity constant. Third one, acute angle is decreasing. Just check if you can't suddenly, by looking at the graph, if you can't judge it, just draw 2-3 points and just draw the angles and check what's happening with the acute angle, decreasing or increasing. So if you carefully look it, you will understand acute angle is decreasing. That's why here, if I draw a tangent line, angle is 0. If I draw tangent line here, there's an angle. Acute angle is decreasing. Acute angle decreasing means what can we say about the velocity? Positive velocity decreasing. Exactly at this point, if I draw a tangent line, velocity is 0. Right? If I draw the VT graph, how would be the VT graph? Velocity is 0 initially. First part, velocity is 0. Then constant positive velocity. Constant positive velocity. Then positive velocity is decreasing. How many of you drew the graph in this way, hands up? How many of you drew the graph in that way, hands up? Raise your hands. 1, 2, only 2. How many of you understood, hands up? If you understood. Okay, now I'll ask from you, right? I'll ask from one thing. Look here. Now, if you have any confusion, the confusion is in case when you converting ST into VT, the main confusion that you have is whether angle is acute or obtuse, what's happening to the acute angle, increasing or decreasing or constant. Upcoming graphs from graph number 10 onwards, do I want to explain by taking 2-3 points on each section? Raise your hands. How many of you want to explain in that way? Now, what's happening to the acute angle or what's happening to the obtuse angle. How many of you need some kind of detailed explanation for each and every graph? Raise your hands. How many of you want in that? Raise your hands. No one, right? So then I think, I hope that you guys knew, because many times I told this thing. Okay, then graph number 9 also done. Graph number 10, I can divide again 3 sections, 10, 11, 12. Graph number 10. Graph number 10, 10th one. Displacement time graph. What's happening here? Is the graph. In this case, now here acute angle. Initially the positive velocity, when t equals 0, there's a positive velocity. When t equals 0, there's a positive velocity. Positive velocity. And here, if I draw a tangent line, at here velocity is 0. Here, if I draw a tangent line, velocity is 0. Here, if I draw a tangent line, there's a positive velocity. Then what's happening in the each section? Each section here, acute angle decreases, positive velocity decreases. Positive velocity decreases. Then here, positive velocity constant. Second one, velocity is 0, because if I draw a tangent line, angle is 0, therefore velocity is 0. Third part, positive velocity acute angle constant, therefore positive velocity constant. Positive velocity decreases from positive value. And velocity becomes 0. Then velocity is 0. Then again positive velocity constant. And now the problem is, now some students have some kind of issue. Now where exactly do I want to mark the positive velocity constant? Because some people can mark like this. Some people can mark like this, but you don't think that much. Now for this type of graph, that it's not a big deal. So therefore you can mark this hero, here. Don't think that much so much. But upcoming graphs, we want to specifically mark the exact location of that positive velocity constant. So I will teach you when we go to that graphs, okay? Then 11. 11 finished answer. 11 finished. Raise your hands. How many of you finished 11th one? 12 finished answer. 12 finished. 12 finished. Okay, do it. Twelve, 13, 14, 15, 12. Now here horizontal, okay? When t equals 0, there is an acute angle. Therefore, when t equals 0, there's a positive velocity. When t equals 0, there is a positive velocity. I say this is t1, it's t1, t2, t3. When the time is t1, if I draw the tangent line at this point, there's an acute angle. So therefore, there's a positive velocity. If I draw a tangent line at the time simple t2, tangent line is horizontal, velocity is 0. If I draw a tangent line at the time is t3, that angle is obtuse angle, therefore negative velocity. I can divide the entire graph into 3 sections, section 1, section 2, section 3. Section 1, section 2, section 3. Section 1, acute angle constant. Therefore, positive velocity constant. Section number 2, acute angle decreases. Therefore, positive velocity decreases. Section number 3, obtuse angle. Obtuse angle is decreasing. Section number 3, obtuse angle is decreasing. Therefore, negative velocity increasing. Negative velocity increasing. That's it. If you can argue these important things, you understood this lesson better. Still, if you have any doubts, if you have any confusion, you should clarify from me. That's a must. From you will trouble. In this case, how would you do the graph? positive velocity constant. Positive velocity constant. Then positive velocity decreases and velocity is 0. Positive velocity decreases and velocity is 0. Further, negative velocity increases. Negative velocity increases. Negative velocity increases. That's it. Raise your hands. How many of you do this graph answer? How many of you do this graph answer? There are many. Very good. Very good. That's it. Then graph number 11 also done. 12th one. Graph number. Oh God. Did I miss any graph? 8, 9, 10. This should be 11. This must be 11. Graph number 12. Graph number 12. Now what's happening? Now in this case, now if I draw a tangent line with the time is 0. If I draw a tangent line, the time is 0. Understand? If I draw a tangent line, the time is 0. Velocity is 0. Velocity is 0. Now, look here. This is somewhat crazy. Now, this graph is somewhat crazy graph. Now, comparing with all the previous graph, this graph is some kind of different graph. You will understand why. Right. Now, look at here. I take this point. When the time is simple t1, when the time is simple t1, I take this point. I enlarge this point. I say this point is, I enlarge. I enlarge when the time is simple t1. This point I enlarge and I draw it for you to understand. I enlarge it for you to understand. This is how it appears. Roughly. Now, if I divide this entire graph into two subsections, section 1 and section 2. Section 1, this is my section 2. Now consider graph number 1, first section of the graph, the last point in the first graph. Everyone stop doing and look here. The last point in this is the first graph, the last point in the first graph. Let's say this is my last point in the first graph. I don't draw exactly that point. I just draw a point just before that last point. If I draw the last point, the important points. If I draw the last point in the first graph, if I draw the tangent, if I draw the tangent, you will understand. If I draw a tangent for the first graph at the last point, at the last point of the first graph, I draw a tangent. What is the angle made by the last point, the tangent drawn to the last point? What is the angle it makes? Reply in chat box. Considering first graph and if I draw a tangent line to the last point in the first graph, Reply everyone chat box. What type of angle does that tangent line make? Obtuse angle. Obtuse angle, right? Obtuse angle. This angle theta 1. If I consider second graph, the first point, what is the initial point in the second graph? Same point. Initial point in the second graph is same point. If I draw a tangent line, considering second graph to the initial point, if I draw the tangent line, what is the angle made by the tangent line? Reply. What is the angle made by the tangent line? Acute. Acute. This is important. Very, very tiny important things that you want to learn from these graphs. Theta 2. Now you want to understand. When I consider first graph, somewhere else draw this one also. When I consider first graph, the last point. When I consider my first graph, last point, angle is obtuse. Therefore, velocity is negative. When the time is simple, when the time is t1, if I consider first graph last point, velocity is obtuse. That means negative velocity. But if I consider second graph, at the initial point, velocity is positive. Positive velocity. That's important thing. When the time is simple t, if I draw a tangent, velocity is 0. This is somewhat important. I don't give notes for these points. I think you can understand. Just write a note by your words. That's it. Now we'll argue usual way. What's happening here? Obtuse angle is decreasing. That means negative velocity increasing. Here, acute angle is decreasing. Acute angle decreasing means positive velocity decreasing. Negative velocity increasing. Positive velocity decreasing. Then if I complete the graph, negative velocity increasing. Initially velocity is 0. Negative velocity increasing. We'll draw the graph in this way. Okay. Negative velocity increasing. Negative velocity. Initial velocity is 0. Negative velocity is increasing. Up to here. Am I correct? Okay. Suddenly what happened? If I consider second graph, initial point is positive velocity. If I start draw the second graph, initial point is positive velocity. And positive velocity is decreasing. Positive velocity is decreasing. Final velocity is 0. Did you understand? Raise your hands. Did you understand this graph? Raise your hands. If you understood this graph, raise your hands. Yes. Okay. 12th one also done. 13, 14, 15. 12 done, 13. Okay. How many of you finished doing 13 hands up? 13 finished. Raise your hands. 13 finished. 13 finished. All of you. 14 finished hands up. 14 done. 15 done hands up. 15 finished. 16 finished. 16. Keep on doing this. For the 13 one. 13. Now I think write some kind of nod by your words mentioning this idea. And put a star for this graph. Put a star for this graph. Star for this graph. Now I hope you guys understand the logic behind this. I think so. Now this graph contains how many sections? 1, 2, 3, 4. There are 4 subsections in the graph. There are 4 subsections in the graph. One, two, three, four. Again, graph number 1, graph number 2, 3. There are 4 graphs. If I draw corresponding VT graph, now again t equals 0, time is 0, t1, this is t2, this is t3, this is t4. Time, simple t. Velocity time graph. So when t equals 0, if I draw a tangent line, when t equals 0, if I draw a tangent line, angle is acute. Therefore, there is a positive velocity. There's a positive velocity. Now again, the same problem comes like how we argued in time t1 in graph number 12. Very similar thing occurring in this point also. Look here. If I consider last point, in graph 1, if I consider last point in graph 1, it's like this, something like this. If I draw the last point in graph number 1, if I draw a tangent line, angle is acute. Right? Acute angle means, understand, positive velocity. Acute angle is positive velocity. If I consider second graph, first point. If I draw second graph, first point, if I draw a tangent line, angle is obtuse. Do you understand? If I consider second graph and if I draw a tangent line to the first point, angle is what? Angle is obtuse. Therefore, second graph initial velocity is negative velocity. This point is also second graph last point. Look here, second graph last point. This understanding you should have, okay? If I consider the time is simple t2, when the time is simple t2, this point. If I consider last point in the second graph, if I draw a tangent line, last point in second graph, I draw a tangent line, angle is obtuse. Therefore, last point in the second graph is also negative velocity. If I consider first point in third graph, if I draw a tangent line, is horizontal. Therefore, velocity is zero. Okay, I think you understand what I'm saying. Now we'll argue what's happened to the velocity. Here, acute angle decreases. That means positive velocity decreases. First part, what's happening? Positive velocity decreases. Second graph, obtuse angle constant. About obtuse angle constant, that means negative velocity constant. Third graph, velocity is zero. Fourth graph, acute angle is increasing. Acute angle is increasing means what can you say? Positive velocity increasing. Then if I plot the graph, then I'm getting that. I'm getting positive velocity decreases. But when the time simple t, object has a positive velocity, okay? Positive velocity decreases. But does not come to zero. Understand that one? You got it? Positive velocity decreases, but does not come to the zero. Even when the time is simple t, object has a positive velocity. The next what's happening? Negative velocity constant. You don't think it's a difficult way of learning? This is the easiest way of learning. You need to argue. This is how you want to practice regarding graph. There are many learn by heart methods, but you don't follow them because they are difficult to remember. And when they ask different ways, because physics means all about something challenging subject and very difficult to think, because different question, even though same unit, they can ask different ways in the same question. So therefore, if you don't apply the right logic, then you can't get the answer. So therefore, learn this way. This is the way that you want to learn. No matter where you go, you want to learn this way. Right? Okay. Right. It takes time, but what to do? Negative velocity constant. The next one, velocity is 0. Velocity is 0. Then positive velocity increases. Positive velocity increases. Raise your hands. How many of you did this graph? Hands. If you did this graph, raise your hands. I think all of you drew the same graph. Then that's it. Then I think the way that I taught you really made you to understand the logic behind these graphs. Then that's it. Is okay. Graph number 14. Graph number 14. How many finished? 14 hands up, 14 done. 14 finished. 15 finished. 15 finished. 16. 16. Many finished. 17. 17. 17 done. 18. 18. 19 done. Very good. 20. Then you finished everything. Wow, great. Then 14. If I draw 14, it's completely all right. You are very slow when you converting these graphs, completely all right. But even though you are slow, you are getting the right graph. That's what important. It's completely okay. You take time, but draw the right graph. Because with the practice, automatically you can increase the speed. If you right now, if you take time and if you draw the right graph, then you have the confidence. No matter any graph in the exam they give, you have the confidence that you can do that, right? So it's okay if you are slow. That's okay. With the practice, you can improve your speed. But if you can get it right, that's what important. Graph number 14. 14. Graph number 14 now. Now look here. I intentionally look here. This graph is somewhat important. Now I intentionally when you compare this gradient and sorry, when you consider this slope and this slope, I intentionally this slope is somewhat low. This slope is somewhat high. Okay, intentionally I drew in that way. Right. We'll argue. Yes. Then we'll argue what's happening to the velocity. Acute angle constant. Acute angle constant, graph number 1, graph number 2, 3, 4, 5. There are 3. 1, 2, 3, 4. There are 5 graphs. What's happening in the first graph? Acute angle constant, positive velocity constant. Positive velocity constant. Second graph, gradient is 0, angle is 0, velocity is 0. Third graph, obtuse angle is increasing. Obtuse angle increasing means negative velocity decreasing. Fourth graph, velocity again 0. Fifth graph, what's happening? Fifth graph, negative velocity constant because obtuse angle constant, negative velocity constant. Then if I draw the graph, if I draw the graph, how would the graph? How would be the graph? Positive velocity constant. Positive velocity constant. Okay. Positive velocity constant. Positive velocity constant. Velocity is 0. Then negative velocity increase, negative velocity decreases. Negative velocity decreases. Negative velocity decreases. Negative velocity decreases and becomes 0. Negative velocity decreases and becomes 0. Then what? Then velocity is 0 again. Velocity is 0 again. Then negative velocity constant. Then negative velocity constant. Negative velocity constant. Now here we'll just check in now somewhere. If you mark somewhere else, that's fine. Okay, you mark somewhere else. Okay. Then graph number 14 done. 15, 16, the last 5 graphs. After we drive these 5 graphs, we'll take a small break and we'll convert VT to ST. Then that's it mainly. Then converting VT to AT to VT is not difficult. I will tell you quickly. We can finish today. So then, right. Now graph number 15. 15, 16, 17. Okay. $15. Okay. 15. Something like this. This graph is important. Put a star for this graph also. Now this graph is important. Okay. Now here, when you argue these two graphs, obtuse angle constant, negative velocity constant, negative velocity constant. Now I say negative velocity v1 constant. This is negative velocity v2 constant. I'll ask a question. Graph number one, graph number two, graph number one, graph number two. My question is, which graph has the larger magnitude of velocity? Right? My question is, so when you consider this graph number one and graph number two, which graph has the larger velocity magnitude? Which graph represents the larger magnitude in velocity? Raise your hands. How many of you say first graph? This one, velocity is larger in first graph. Hands up. Velocity is large in first graph. Hands up. Velocity is larger in second graph. Hands up. Velocity is large in second graph. Now, how do you argue? Just argue the obtuse angle. Now, what happened? Now, here, if I draw the obtuse angle, we know that, look here. If I draw a tangent line here, this obtuse angle I say theta 1. This obtuse angle I say theta 2. Then we know that comparing with obtuse angle theta 1 and theta 2 is larger. Obtuse angle is larger in theta 2. The obtuse angle is larger in theta 2. Large the obtuse angle, we know that obtuse angle means negative tan theta. Obtuse angle means negative tan theta. Larger obtuse angle means understand. Larger obtuse angle means lesser negative tan theta value. Lesser negative tan theta. Gradient is less. Negative gradient is small. Right? Negative tan theta 2 is negative tan theta 2 gradient negative gradient is small. Smaller the obtuse angle, large the negative tan theta. Negative tan theta means negative gradient. First graph has large negative gradient. Second graph has smaller negative gradient. Larger negative velocity, smaller negative velocity. Then how would you do the graph? This is an important graph. Put a star. Then I am getting larger negative velocity belongs to first graph. Larger negative velocity. Negative velocity V1. Smaller negative velocity belongs to second graph. Smaller negative velocity. Smaller negative velocity. Minus V2. Anyone do this way answer? Anyone do this way answer? 1, 2. There are 2. Then 17. Okay, then 16. 16. So if I draw 16, graph number 16. So in this case, displacement time graph 16. In this case, I can divide this graph into four sections. Four sections, right? If I divide into four sections. One, two, three. This part is four. So then I'm getting here, first one is acute angle constant, positive velocity constant. Positive velocity constant. Second graph, velocity 0. Third graph, obtuse angle, negative velocity constant. Fourth graph is also obtuse angle, negative velocity constant. But look, I'll ask a question. Just think about third graph and fourth graph. When you consider third graph and fourth graph, what can we say about the obtuse angle? Both the graphs, obtuse angle is constant. When you compare third and fourth graph, what can you say about the obtuse angle of them? First option is obtuse angle at third graph and obtuse angle in fourth graph. Both are equal. Second option is obtuse angle is larger in third graph. Option number 3 is obtuse angle is smaller in third graph. Raise your hands. How many of you say obtuse angle are equal? How many of you say obtuse angle are equal in third graph? Third and fourth obtuse angle equal. Because they are equal, right? If they are equal, both of them have same velocity. Understand? That's the important point. Okay, I will give a note when I come to here. We'll do the graph positive velocity constant. Positive velocity constant. Velocity 0. Negative velocity constant. Negative velocity constant. Sorry, negative velocity constant. Okay, negative velocity constant. But you want to understand the negative velocity constant. In that section also same negative velocity. The same gradient, there was same negative velocity. See, when you compare graph number 3 and 4, if you compare graph number 3 and 4, compare graph number 3 and 4. Because this type of important points, I can't give a separate note. So therefore, by converting each graph, we learn something. So every graph, there is something to learn. Then if I say obtuse angle is theta 3, obtuse angle is theta 3, mark everything I do. I write this obtuse angle is theta 4. The we know theta 3 equals theta 4. They are obtuse angle. So therefore, we can say that tan, they have negative tan theta values. Ni? Because obtuse angle is tan theta 3. Ni? Tan theta 4. So therefore, they have same negative velocity. Negative velocity V3, negative velocity V4. Both of them have same negative velocity. Same idea. The graph number 17. We have 4 more graphs, then we'll take a break. I think we have 4 more graphs. Then we'll take a break. Right. Graph number 17, 18, 19, 20. 17 done, hands up. 17 done, raise your hand. 17 done. 17 finished, 17. 18 finished, answer. 18 finished. 19 finished, answer. 19 finished. 20 finished. 20 finished. I think most of you have done. Very good. Okay. Now 17, 18, 19, 20. 17. If I draw the VT graph, the VT graph. If I draw the VT graph. Now obtuse angle is decreasing. That means negative velocity increasing, obtuse angle constant, negative velocity constant, acute angle constant, positive velocity constant. Okay. Now in here is also understand negative velocity increasing from zero velocity, because if I draw a tangent line at t equals 0, velocity is 0. Here velocity is 0. So therefore negative velocity increases. Negative velocity increases. Look here. Now this is also important. Now look here. Now negative velocity increases. It's also important graph. Now if I draw the first part and second part, if I draw first part and second part, first part, and if I draw second part, the last point in first graph, if I draw a tangent line, then I am getting obtuse angle. If I draw a tangent line to the first point in second graph, then also I am getting obtuse angle. But the problem is, someone tell me, raise your hands, how many of you say that these two obtuse angles are equal? If I consider last point and if I do an obtuse angle, and if I consider first point and if I do a tangent line, that obtuse angle, raise your hands, they are equal, they are different. Raise your hands, they are different. Obtuse angles are different, raise your hands. They are different actually. And also when you very carefully look that, this red color one obtuse angle is like this. Blue color one obtuse angle is, if you look at this, blue color one obtuse angle is like this. So blue color has large obtuse angle. Am I correct? If you very carefully note here, blue color first point in second graph has large obtuse angle. Right? Obtuse angle is larger. Theta 2 is larger than theta 1. And then larger the obtuse angle means smaller the negative velocity. Large the obtuse angle means, understand, smaller negative velocity. Smaller negative velocity. Smaller the obtuse angle means large negative velocity. So therefore you should start drawing your second graph. Now this is your minus V1. Look here. This is your minus V1. You should start drawing second graph. Negative velocity V2 is smaller. Negative velocity V2 is smaller than negative velocity V1. This is V1 negative velocity. You should start drawing second graph somewhere here. Right? Then positive velocity constant. Positive velocity constant somewhere here. Raise your hands. Did anyone draw in that hands? Especially this point. Up to now, everything is very clear. Raise your hands. Whatever I taught you, up to now, everything is very clear, hands. Whatever I taught you, everything very clear. Raise your hands. Yeah, up to now, everything is very clear. Yes. Next one is right. 18, 19, 20. Last three. 18, 19, 20. It seems that very complex these things, but they are not complex as you think. With the practice, very first time when we learn these things, it seems like they are complex. But with the time when you practice them, you understand they are nothing. That's the logic. So then 18, 19, 20. Graph number 18. Then here acute angle increasing, initially 0, acute angle increasing, positive velocity increasing. Here velocity is 0. Here negative obtuse angle is increasing. Obtuse angle increasing means negative velocity decreasing. If I draw it, initial velocity is 0, here velocity is 0. Then here is also velocity is 0. That case, positive velocity increasing. Positive velocity increasing. Velocity is 0. Negative velocity decreasing. This height and this height will be same. Negative velocity decreasing. That's it. 19. Something like this. ST. Right? 19 says that acute angle constant. Acute angle constant means positive velocity, I say V1 constant, positive velocity, I say V2 constant. Now you know that large the acute angle, because this acute angle is larger than this acute angle. Large the acute angle, we know that large the positive velocity. So therefore, I can say that plus V2 is larger than plus V1. So therefore, if I draw it, plus V1 is here, plus V2 is here. The last graph, then we can take a break, last graph. So if you do the last graph, 20, last graph will be something like this. Here, what's happening here? In here, what's happening? In here, obtuse angle is increasing. Obtuse angle increasing means negative velocity decreasing. Again, here, acute angle increasing, positive velocity increasing. Negative velocity decreasing, positive velocity increasing. Negative velocity decreasing and positive velocity increasing. Negative velocity decreasing, positive velocity increasing. Did you understand? Raise your hands, whatever I taught you from this 20 graphs, very important. Every question, I think it gave a good understanding about how to apply the theory that you learned. We discussed 20 conversions, ST to VT. After the break, we are converting VT to ST also. I think roughly 20. I can't remember the number of questions. Did you really understand whatever we learned in motion graphs up to now? Raise your hands. If you understood everything, raise your hands. Yes, okay. Can we slant the second line a bit? Now we can't slant. Okay, look here. That is also somewhat important. Look here. Now we can see that now. This is some kind of symmetric. You can understand this curve and this curve, some kind of symmetric one. So then if you slant it, If you slant it like this, if you slant it like this, then it's not belongs to symmetry. Now this is very symmetric. The way how it negative velocity decreases, very similar way positive velocity increases. So therefore, this should be one line. This should be one line, right? So if you slant it, that's somewhat wrong because symmetric, the symmetric means same one line. I hope you understand. They will take a break and come down. Did you notice any issue now comparing with last classes the voice and comparing with last classes my voice and today my voice? Do you feel, are you feeling any kind of issues in my voice? Just reply if you notice something. Sometimes the way that you notice and other one notices something different. If you notice something, just reply. Did you feel any difference in the voice? Raise your hands. Anyone felt any difference? Everything is fine, right? Okay, they will take a break. We'll take a break. Now time is exactly 8:50. Come at 9 o'clock. Come at 9 o'clock. Come at 9 o'clock. Right. Bro. Yes, someone reply if you can hear me speaking. Just reply it. If you can hear me speaking, just reply it. Okay, right. And then now I hope you guys understood how to convert ST graphs into VT graph. What you want to look in ST graph is the gradient. Because if you want to obtain VT graphs, you should know how velocity varies with the time. Am I correct? If you want to know the VT graph, you should know that how velocity varies with the time. In ST graph, gradient represents velocity. Therefore, what we check always gradient in ST graph, because gradient in ST graph represents velocity. So therefore, we check the variation of gradient in ST graph. Then that is velocity variation in VT graph. That's the idea. Okay. Now we are converting VT graphs into ST graphs. We are converting VT graphs into ST graphs. Okay. Right. Give me a second. Right. Okay. Now I'll give the note. I will give the note. Okay. Before now, put your topic conversion. Put your topic conversion of VT graphs into ST graphs. Conversion of VT graphs into ST graphs. I will give the note a little bit later. Idea is very simple. In page number 22, question number 2, they say that draw ST graph for below VT graph. That means they have given set of VT graphs. We want to convert to ST graphs. Previously, we converted ST graphs for. Previously, we converted ST graphs into VT graph. Now we are converting VT graphs into ST graphs. Now I will advise how you want to do that. Now what you want to do is here, whatever happened to the y-axis in VT graph. Follow what I'm saying always. Whatever happened to the y-axis in VT graph should happen to the gradient in ST graph. Okay. converting VT graphs into ST graphs. Whatever happened to the y-axis in VT graph should happen to the gradient in ST graph. Y-axis in VT graph. Y-axis in VT graph should happen to the gradient in ST graph. Should happen to the gradient in ST graph. Gradient in ST graph. So we'll write down this. We'll write this note. Okay, we'll write this note. First of all, we'll do the conversion, and at the end we'll write the note. Okay. Right. Now we'll go to that question. We'll go to we'll go to in page number 20. Page number 22. We'll understand how we convert VT into ST by doing these questions. We'll go to question number 1. Question number 1. Question number 1. Yes. VT graph into ST graph. VT graphs into ST graphs. Whatever happened to the y-axis? Now, very carefully, so now you might confuse. There's a problem. If I only teach you converting ST to VT, now you get the idea and you do correctly. But suddenly, if I start explaining the opposite also, what students they do, they confuse. Because previously they learned when converting ST to VT, because now they have the practice checking gradient in the first graph. So if I ask them to convert VT to ST, what they do, they check the gradient here. They forget in VT graph, they want to check Y. In ST, they want to check gradient. They confuse with that. So therefore, please don't confuse. If you want to convert VT to ST, check the y-axis. Check the y-axis. Please check the y-axis. Now, someone tell me, okay, if I divide this graph into 2 subsections, graph number 1 and graph number 2, reply everyone, what can we say about the first graph, velocity? Like previously that we explained. Previously, I explained that positive velocity constant, positive velocity increases, negative velocity decreases. I need a statement for first section of this graph. Reply in chat box, what can we say about the velocity of graph part 1? Reply in chat box, everyone. Check the y-axis. Everyone, I'm expecting answers from everyone. Quickly. So I got only one answer. You should reply for sir, SIR sir. I think I renamed. No, don't compare. I didn't ask you to compare first graph and second graph. I asked you to tell, we'll compare later. I asked that, what can you say about the velocity in first graph? What about the second graph? I'm asking, what can you say about the first graph? Positive velocity constant. Am I correct? Look at the y-axis. This time y-axis is my velocity. Above time axis positive y, below time axis negative y. positive velocity constant. Positive velocity constant. Second graph also positive velocity constant. Look at the y-axis. Don't look at the gradient now. Look at the y-axis. Look at the y-axis. Now look at the y-axis. When you look at the y-axis, this is also positive velocity constant. And now tell me, what can you say about the velocity v1? That means velocity in first graph, and what can you say about the velocity v2 in second graph? v1 is larger than v2. We can understand v1 is larger than v2. And now how do we convert this given data into gradient? Positive velocity constant. Now look here. Positive velocity constant means, now think about the gradient ST graph. Positive velocity constant, how do you plot in ST graph? Positive velocity constant means in ST graph, gradient is velocity. ST graph, gradient is velocity. Positive velocity constant means positive gradient constant in ST graph. Positive velocity constant means positive gradient constant in ST graph. Positive gradient constant means obviously acute angle constant. Acute angle theta 1 constant. Constant. Acute angle theta 1 constant in ST graph. How do you draw constant acute graph? Constant, acute angle constant. Acute angle constant. Now, when you converted ST graphs into VT graph, thinking about the variation of angle, and you drew the VT. Now, when converting VT to ST, you check the y-axis of VT and you come to the conclusion about the angle. That's it. Completely opposite thing. Acute angle constant. Acute angle constant means acute angle constant. Something like this, acute angle constant. Now we know that second graph is also constant acute angle. Second graph also constant acute angle, am I correct? But we know that second graph is also, if I explain, positive velocity constant means positive gradient constant in ST graph. That means positive, that means acute angle, positive acute angle constant. Acute angle constant, that means theta 2. Constant in ST graph. What can you say about the theta 1 and theta 2? Which one is larger? Reply everyone. Raise your hands. How many of you say theta 1 is larger? Raise your hands. How many of you say theta 1 is larger? How many of you say that theta 1 is larger? When you compare theta 1 angle and theta 2 angle, how many of you say theta 1 is larger? Theta 2 is larger. Raise your hands. How many of you say theta 2 is larger? Because acute angle, look here, V1 is larger than V2. These are acute angles. That's the thing. Now you might start confusing. V1 is larger than V2. Then they are positive velocities. They are positive velocities. Both of them have positive acute angles. Larger the positive velocity, larger the acute angle. Smaller the positive velocity, smaller the acute angle. So therefore, theta 1 is larger than theta 2. Plus V1 larger than plus V2. So therefore, theta 1 acute angle larger than theta 2. Then when you are drawing the second graph should have small acute angle. Second graph should have small acute angle. Raise your hands. Did you understand? Did you understand? Raise your hands. Now we check the y-axis and we think about the angle. Now this time we check the y-axis and we think the angle. That's the thing. Now check the y-axis and think the angle. Previously we thought the angle and we checked the. Previously we thought the angle and we came to the conclusion about y variation. Now we check the y and we think the angle opposite. So when you do 2-3 questions, you will understand. Give your 100% effort to understand. Now don't think now you have recordings, but don't think that okay, I will rewatch the recordings again. Don't do that. Within the time itself, try to give your 100% effort and try to understand right now. Then you don't need to watch it again. Then you will make the right idea. Oh, graph number 2. Graph number 2, because I can guarantee that no anywhere thing is anywhere you learn that they don't explain this way, especially English medium classes, they don't do actually. Therefore, get the maximum benefit from me. Second one, graph number 2. Now always check the y-axis in the VTA graph. Check the y-axis. Check the y-axis. Always check the y-axis. Always check the y-axis. Always check your y-axis. Now here what's happening? What's happening to the y-axis? Part 1, part 2. This is part 1. This is part 2. Check the y-axis. In part 1, positive velocity constant. Check the y-axis. Positive velocity constant. Check the y-axis, okay? Positive velocity constant with the time. Positive velocity constant. Check the y-axis. Second part. Check the y-axis. Positive velocity increasing. Positive velocity constant. Second graph. Positive velocity positive with the time. Positive velocity increasing. Okay. Positive velocity increasing. Then how do you represent positive velocity constant in ST graph? Positive velocity constant. ST graph gradient is velocity. Positive velocity constant means positive gradient constant. Positive velocity constant means positive ST graph. In ST graph, positive velocity constant means positive gradient constant. Positive gradient constant means acute angle constant. Acute angle constant. Now here I can say that acute angle constant. So first in a few graphs, I will detail, I'll write down. Okay. So graph part 1. Positive velocity constant means I can say that positive gradient constant in ST graph. ST graph. ST graph. Positive gradient constant means I can say positive gradient constant means acute angle constant. Acute angle constant. Acute angle constant. Okay. Acute angle constant. Right. So then graph number part 2. Part 2, positive velocity increases. Positive velocity increases means in ST graph. In ST graph, I can say that positive velocity increasing means positive gradient increasing. Positive gradient increasing. Positive gradient means acute angle increasing. I told you these things. Acute angle increasing. And now I understood initially acute angle must be constant, then acute angle must be increasing. How will we draw that? Constant acute angle. Constant acute angle. Like this. Constant acute angle. Then acute angle is increasing. Constant acute angle, then acute angle is increasing. Then acute angle is increasing. Acute angle is increasing. The second part must be some kind of curvy one. Second one must be some kind of curved one. Raise your hands. Did you understand? If you understood first two graphs, raise your hands. You go home. That means after class finished, we do it again. Then you'll definitely understand. Raise your hands. First two graphs, if you understood. The third one. The third one. Third one. Third one. I hope next week we can start vectors also. Next week we can finish. There's one more part in motion graphs. We can finish motion graphs, and next week I think we can start vectors roughly. Right. So waiting until your result comes. We'll see this end of this month. I think your result will come. If not, most probably December first week. So we'll see. Graph number 3. VT to ST. Something like this. In check the y-axis. Check the y-axis. If I consider first part, what's happening to the y-axis? Velocity. With the time, positive velocity increases. Check the y-axis. Check the y-axis. Positive velocity increases. Second one, positive velocity constant. Check the y-axis. Positive velocity constant. Positive velocity means, now you know that positive velocity means acute angle. Positive velocity means acute angle increasing. The acute angle increasing. Positive velocity increases means, now we know that Acute angle increasing. Acute angle increasing. Positive angle constant means we know that acute angle constant. Acute angle constant. Then how do we draw acute angle increasing? Acute angle increasing. Now, next important thing is, I will give these notes, don't worry. Now, previously, I think I explained that VT graphs, there can be discontinuities. That means the point where one of the graph, the point where one part of the graph finishes, it's not compulsory to start second graph in the same finish point. That means in VT graphs, there can be discontinuities. But understand, ST graph, there can't be discontinuities. For an example, if that graph contains many subgraphs, subsections, if that graph contains many subsections, the point where first subsection finishes, second subsection must be drawn from the point where first graph finishes. For example, in ST graph, now I'm drawing a ST graph. The point where first part finishes, second part must be drawn from the point where first part finishes. There can't be any discontinuities in ST graph. I will give us a special note after we convert this one. Okay, don't you worry. Okay, I will give us a special note. Then what you want to understand is, or you should understand, ST graphs, there should not be any discontinuities. VT graph, there can be discontinuities. That's it. If you understand that one, that's it. Okay, right. Then third one. Third one here, acute angle increasing. Acute angle increasing. Acute angle increasing. Acute angle increasing. From that acute angle constant. From that acute angle constant. Now, with the first time, as this is your first time that you are drawing these conversions, what's now some people might have drawn the same graph, but I think most of, I don't know whether you did in that way, most of you have drawn this graph in this way, like this first part, like this. Raise your hands now, section wise. When you apply the logic, this graph is correct. Raise your hands. How many of you drew the graph exactly this way? Hands. How many of you, rather than a smooth flow, how many of you drew this graph exactly this way? Hands. Because with your first attempt, I think most of you drew in this way. If you separately apply the logic, that's correct. This one and this one seems same. But understand this is wrong. Because why it's wrong? Why it's wrong? Why it's wrong? The reason is, look here. What can you, if I take this region, if I enlarge it, understand? If I enlarge it, very carefully listen. I take the last point. Look here. I take the last point in the first graph. And I take the first point in the second graph. Tell me, everyone tell me, just because now you need to understand last point in the first graph and first point in the second graph, they are the same point, okay? Tell me that last point in the first graph and first point in the second graph, they are same point. Tell me, what can we say about their velocities? Must be same. Am I correct? Right? Let's say now, the last point in the first graph velocity and first point in the second graph velocity, they are same actually. But if you represented your ST graph in this way, do you think that the idea is, if you convert, okay, if someone have drawn this graph, if you convert to VT graph, then I should obtain this graph, okay? If you convert this graph into VT graph, I should obtain this graph exactly. Now we don't, shall we convert this ST to VT again? If I convert this ST to VT, what will happen? What will happen? Yes, acute angle increases. Therefore, positive velocity increases. That part, okay. Now, what is the meaning of this point? If I take a point in, if I take the last point in first graph, if I take a point, if the point, the last point in the first graph, if I draw a tangent, acute angle theta 1. If I take a point, first point in the second graph, if I take the angle, that is also acute theta 2. But it seems like theta 1 is larger than theta 2. That means second graph should be started bit lower. This is the meaning of, if someone have driven in this way, when you convert to VT, this should be your VT. But we should get this one. Did you understand? So therefore, understand there should not be any some kind of I don't know the word to say. So there can't be something like this. There should be a smooth flow like this. Did you understand what I'm saying? Raise your hands. You really understood what would be happen if you do this way, hands up. Did you understand what I explained? What would happen if I do this way, hands up? Did you understand? I think you guys raise your hands. I don't know how many of you understand. Okay. Right. Therefore, there must be a smooth way. So then only you can say that if you take the last point in first graph, that angle, and if you take the first point in the second graph, that angle, both are same. So therefore, same velocity at the last point in first graph and first point in second graph. That's the idea. Then I hope you guys understand. Fourth one done, hands up. How many of you finished doing fourth one? Fourth one done, raise your hands. Fourth one finished. Fifth one finished, hands up. Fifth one finished. Sixth one finished, hands up. Just do it. Then I'll do fourth one, 4, 5, 6, 7. Don't worry, every mistake you will learn something. If we don't mistake, we don't learn anything new. If you do a mistake only, the thing that you learn from a mistake will remember forever. So therefore, it's completely all right if you do mistakes, but every mistake you must learn something. If you don't learn something in your mistakes, then that's a big problem. So therefore, you have enough time to do mistakes until your AL exam. Until your AL exam, do mistakes completely all right, but every mistake you must learn something. If you don't learn something in every mistake, then there's a problem on you. Problem with you. Fourth one. Graph number 4. Graph number 4. Again, I can divide into 3 sections. Always look at the y-axis. Always look at the y-axis. If you look at the y-axis, this one, positive velocity constant. This one, positive velocity increasing. And you look at the y-axis. Look at the y-axis. Positive velocity increasing. This one, positive velocity constant. This velocity v1, this velocity is v3. v1, v3. Then positive velocity constant means we know acute angle constant. Acute angle constant. Acute angle constant. Acute angle constant. Then here, sorry, yeah, positive velocity constant means acute angle constant. Positive velocity increasing means acute angle increasing. Again, positive velocity constant means acute angle constant. Okay. Part 1. Positive velocity constant means acute angle constant. Acute angle constant. Acute angle means theta. As a theta 1 is constant. Then part number 2 means positive velocity increases. That means positive velocity increasing means acute angle. Acute angle is increasing. Acute angle is increasing. Then part number 3 is positive velocity again constant. Now acute angle is theta 3 constant. Look here. I'll ask a question. Reply in the chat box. I'll ask a question. Acute angle constant in first graph. Acute angle constant in third graph. Acute angle in first graph is theta 1. Acute angle in third graph is theta 3. Which one is larger? Raise your hands. How many of you say theta 1 is larger than theta 3? Hands up. Theta 1 is larger than theta 3. Hands up. Theta 1 is larger than theta 3. Hands up. Theta 1 is smaller than theta 3. Hands up. Theta 1 is smaller than theta 3. That's the idea. Okay. Then we know theta 1 is smaller than theta. That means theta 3 is large. If you draw this one, acute angle, this angle is theta 1. This angle must be theta 1. Now acute angle is increasing. Look here, same thing. Don't. You should maintain the flow, smooth flow. Don't break the graph. With the practice only, you'll get that. Acute angle increasing, the curve. Now you can understand this theta 3 is large. So if you do this angle, theta 3 is large. Theta 3 is larger than theta 1. Right? I think you guys understand. Graph number 4 done. Graph number 5. 5, 6. Graph number 5. Graph number 5. Now part 1, part 2. Part 1, this is part 2. Acute angle, see? So, okay, look here. Check the y-axis. Check the y-axis. If we check the y-axis, always check the y-axis. When I check the y-axis, positive velocity increases. Positive velocity increases. Okay. Positive velocity increases. Now, if you check the second graph, look here, positive velocity, just think the second graph, look at the y-axis. What's happened with the time? What's happening to the y-axis? Check only that. With the time, what will happen with the y-axis? Positive velocity decreases, finally becomes zero. Positive velocity decreases, finally becomes zero velocity. Initial velocity also, look at the y-axis. Look at the y, don't think the gradient. Look at the y-axis. When t equals 0, look at the y-axis. When t equals 0, look at the y-axis is 0. Look at the y-axis now. Most of you start thinking about the gradient. Don't think gradient in converting VT to ST. Look at the y-axis. In that case, okay, positive velocity increases, positive velocity decreases. That means part 1, positive velocity increasing means, okay, positive velocity increasing means we know that acute angle increases. Then what will happen? Part number 2, positive velocity decreases, acute angle decreases. Acute angle decreases. This is the idea. Then velocity is 0. This is how your graph would be. Acute angle increases. Acute angle increases. Now acute angle, the point where you finish first graph, understand, the point where you finish first graph, second graph must be started from the point where you finish first graph. Second graph, acute angle is decreasing. Acute angle is decreasing, finally velocity is 0. Finally velocity is 0. That means horizontal. First also, if you draw the gradient in ST graph, gradient is 0, velocity is 0. Finally also velocity is 0. If you draw the gradient, velocity is 0. Raise your hands if you draw this graph answer. If you draw the graph, raise your hands. Many brave. Very good. Five done. 6, 7, 8. 6, 7, 8. Now sixth one. ST. Check the y-axis. First part, positive velocity increasing, initial velocity is 0. Velocity increasing. Positive velocity constant. Check the y-axis. Positive velocity constant. Check the y-axis. Positive velocity decreasing. Part 1, part 2, part 3. Part 1, part 2, part 3. Positive velocity increasing, that means acute angle increasing. Positive velocity increasing means acute angle increasing. Positive velocity constant means acute angle constant. Positive velocity decreasing means acute angle decreasing. That's the logic. Now this time acute angle increase. Initial velocity also 0, final velocity also 0. Okay, curve. Acute angle constant. Acute angle constant. Acute angle decreasing. Final 0. Now I know when you draw the graph, because you don't have the practice, when you draw the graph, you guys draw this way. You guys draw like this. No, even though you try to draw it, what you do, it's difficult to draw because you have no practice. But you know the logic, what's happening. But when you draw it, sometimes so it's a bit difficult to draw the right graph. But with the practice, it'll be okay, right? But try to draw this way. It's the important. Okay. Right. Graph number 7. Graph number 7. Graph number 7. Yes. The time is going so quickly, but what to do? Okay, graph number 7. Graph number 7. Seventh one. Graph number 7. These two gaps are same gap. Same gap. So, same gap. If you convert to ST graph. Now, okay. Now here, first part number 1, part number 2. Part number 1, this will be part number 2. Now, if I say that what's happening here, just check the y-axis. Always check the y-axis in VT graph. Check the y-axis in VT graph. Positive velocity constant. Part number 2, negative velocity constant. Right? Then part number 1. Part number 1, positive velocity constant means acute angle constant. Part number 2 means we know that negative velocity constant means obtuse angle constant. Obtuse, O for obtuse, A for angle, obtuse angle constant. Right? If I try to draw positive angle constant, positive angle constant, acute angle constant, I have to draw something like this. like this. Now I want to draw obtuse angle constant. Look here. Next, I want to draw obtuse angle constant. Right? Obtuse angle constant. Okay. Now, okay, look here. Now, some points are very tricky points. Now, when you consider first part, that is positive velocity, second part, negative velocity, constant, constant. Just think about the magnitude in first graph, magnitude of that positive velocity, and just think about the magnitude of negative velocity. Their directions are different. That's true. Positive velocity means right side direction velocity. Left side velocity, negative velocity means left side direction velocity. But just think about the y-axis. The magnitude is, if I say plus 5 ms minus 1, negative velocity means minus 5 ms minus 1. This gap is same. So therefore, understand, I will tell you small important points now. Look here. If you plot the graph, if you draw this way, look here. Now, positive velocity constant, negative velocity constant. But now, how do you draw? How do you draw when you are drawing that ST graph? How do you draw in such a way both of them? Now, when you draw the graph, look here. When you draw the ST graph, how do you draw ST graph in such a way both the parts have same magnitude in the gradient? How do you draw ST graph? Now we understood magnitude of that positive velocity and magnitude of the negative velocity. Plus 5 ms minus 1 minus 5, 5, 5. Magnitude are same. How do you show both of them have same magnitude? This is also write down with your words. Okay, how do you show both graphs have same magnitude, even though their direction is different? Acute, obtuse, even though their direction is different, how do you show both of them have same magnitude in the velocity? Both of them have same gradient. How do you show? By drawing the graph in symmetric way, right? So if you draw the symmetric one, now this is acute, this is obtuse, but if you draw the symmetric way, the symmetric of this graph, if this is your mirror, the image of this one, it will be like this. Do you understand? So then this, now rather than someone drawing exactly the image mirror of this one, if someone have drawn this way, if someone have drawn this way, someone have drawn this way, they are not 100% accurate, they are wrong actually. But as it is your initial stage, sometimes even I explain this much deep, I don't know how many of you understand. Okay, tell me how many of you understand, sir? Did you understand? Raise your hands, how many of you understand? Okay. Now, next important thing is I need all of your notes perfectly completed, because you know that now every year now still I could not start a physical batch. That's the problem. I could not start the physical batch yet, but usually it's exactly symmetrical, because they are both of them should have same magnitude, because both of them have same magnitude in the velocity. Magnitude of the gradient, magnitude of their gradient sign is different, positive gradient, negative gradient, but their magnitude is same. How do you ensure, how do you draw in ST graph same gradient? First part will be acute, second part will be obtuse. How do you draw confirming same gradient? Draw the mirror of first one. If this is your mirror, draw the mirror in this one. Then you can say magnitude of these two are same. Their magnitudes are exactly same. So usually what you do, you want to maintain your notes nicely, because I asked someone, one student, I asked from one student to send the note. Then that note will be developed for next batch. That's how I'm going, because I don't keep any note. For that instant, I go through previous students' notes and I just go through it. Okay, keep on doing. How many of you have finished eighth one answer? Eighth one done, hands up. Eighth one, hands up. Eighth one finished. Nine finished, hands up. Nine. Ninth one. 10 finished, hands up. 10 finished. 11 finished, hands up. 11. 12 hands up. No one. Okay. Do it. Time is 9, 10 o'clock. Okay, we'll do. Somehow we'll do. Okay. 10, 11, 12. 10, 11, 12. 10, 11, 12. 10th one. Sorry, I didn't draw only 7. Ni. 8, 9, 10. Ni. 8, 9, 10. 8, 9, 10. Something like this. Now in here, look at the y-axis positive velocity constant. Positive velocity constant here, negative. Ni. Look here. Sorry, my bad. Okay, positive velocity constant. Look here, what's happening to the. That's why even I also sometimes confuse. Look at the second part. Positive velocity decreases. Second part, positive velocity decreases. So then acute angle constant, acute angle decreases. Acute angle constant, acute angle constant, acute angle decreases. Finally, 0. Finally, tangent horizontal. That's the way. Graph number 9. Ninth one, something like this. Graph number 9. Now they are somewhat uh, now look here, if I consider graph number 9, what's happening? Just check up the y-axis. Y-axis, positive velocity decreases. Positive velocity decreases. Positive velocity decreases. Now here, second graph, positive velocity increases. Positive velocity increases. That means acute angle decreases. Acute angle decreases. Here, acute angle increases. Acute angle decreases. Acute angle increases. How do you draw acute angle decrease and increases? Acute angle decrease and increase. How do you draw it? Acute angle decrease and increases. Acute angle decreases. Acute angle decreases. Acute angle increases. Now here, look here. Exactly here, velocity is 0. Look at the y-axis, velocity is 0. Velocity 0 means when you draw a tangent line at the ST graph, at that point, horizontal tangent line, then acute angle increases. Is the graph. Graph number 10, 10th one, something like this. Graph number 10. 10th one will be like this. Okay. Now here, look at the y-axis, positive velocity decreases. Positive velocity decreases. Here, velocity 0. Here, positive velocity constant. Positive velocity constant. Then look here, positive velocity decreases. That means acute angle decreases. Acute angle decreases. Velocity 0 means acute angle also 0. Angle 0. Angle 0. Acute angle constant. How do you draw that? Acute angle decreases. Right? Then acute angle 0. Then acute angle constant. Do you understand? Graph number 11, 12, 13, 14. 11, 12, 13, 14. 11. Graph number 11. 11th one. Now look here. Now check about the y-axis. Again, positive velocity increases. Positive velocity constant. This one, take the y-axis, positive velocity increases. Acute angle increases, acute angle constant, acute angle increases. Acute angle increases. Acute angle constant. Acute angle increases. Raise your hands up to now. Everything is very clear. Raise your hands up to now. Everything is very clear. If you understand up to, raise your hands. Then graph number 11 done. Graph number 12, 12, 13, 14. Graph number 12. Graph number 12. Graph number 12. 12, I think I went wrong. In this case, we know that positive velocity decreases. Look here, y-axis positive velocity decreases. Now here, positive velocity constant. That means acute angle decreases. Acute angle decreases, acute angle constant. Acute angle decreases. Acute angle decreases. Acute angle constant. $13. Raise your hands. How many of you finished doing 13? Hands up. 13 finished. 13 finished. 13 finished. Raise your hands. 13 done. 14 done. 14. 15 finished. Do it. $13. Graph number 13. Okay. Now graph number 13, look at the y-axis. Y-axis positive velocity decreases. And here velocity is 0. Y-axis here negative velocity increases. Y-axis, okay, negative velocity. Y-axis negative velocity increases. Negative velocity increases. Y-axis negative velocity increases. That means, okay. Now look here. Now this is somewhat new, okay. Negative velocity increases means somewhat new for us, because positive velocity decreases means acute angle decreases. Stop, look here. Positive velocity decreases means we know that acute angle decreases. Negative velocity increases. Just think about the ST graph. Negative velocity increases. Negative velocity means obtuse angle. Negative velocity increases means ST graph negative gradient increases, because velocity is the gradient in ST graph. Negative velocity increases means negative gradient increases. Negative gradient increases means obtuse angle decreases. Obtuse angle decreases. Now this point is important. Negative velocity increasing means Negative gradient increases, that means obtuse angle decreases. So therefore, understand here, obtuse angle must be decreasing, okay? Obtuse angle, somewhere else write down. Negative velocity increasing means negative gradient increasing. Obtuse angle decreases, write down somewhere here, okay? When you're converting somewhere, write down, write down. And then if I draw the graph, acute angle decreases. Acute angle decreases and becomes 0. Tangent horizontally. Then from here onwards, obtuse angle increases. Obtuse angle increases. Then obtuse angle increases. How do I draw increasing obtuse angle? So sorry, my bad. Okay, negative velocity increasing means understand. Obtuse angle decreases. Okay, obtuse angle decreases. How do I draw obtuse angle decreasing? Got it. Check obtuse angle decreasing. Raise your hands if you understood graph number 13. Hands up. Graph number 13, do you understand? Hands up. Okay. The time is 10:15. Okay, but somehow we'll complete this today. Then 13, we have 7 more. 13, 14, 15. 13, 14, 15. 14, 15, 16. 14, 15. If I draw 14. If I draw 14. If I draw 14. If I draw 14. If you draw a ST graph. Okay. If you draw a ST graph. Again, check the y-axis. Positive velocity decreases. Positive velocity decreases. Here, positive velocity is 0. Here, negative. Look here. Here, negative velocity constant. Negative velocity constant. Look at the y-axis. Negative velocity constant. Then how do you draw that one? Positive velocity decreases. Positive velocity decreases means acute angle decreasing. Acute angle decreasing. Then 0. Negative velocity constant. Negative velocity constant means obtuse angle constant. Obtuse angle constant. Obtuse angle constant. Okay. Obtuse angle constant. Now one can finish. Now we don't have specific idea. Now one can finish like this. It's okay. Even you finish like this, so like this, that's fine. Now it's okay. Okay. Even though you finish this way or this way, that's completely all right. No big impact. Then graph number 15. Graph number 15. 15, something like this. 15, okay, now there's a, now 15, you don't draw in that way, draw this way, okay? Okay. When you are drawing 15, please draw this way. Symmetric way. Okay, draw this way, okay? Don't extend more. Now here what's happening? Here negative velocity decreasing. Look here, check the y-axis, negative velocity decreasing. Here velocity is 0. Here positive velocity increasing. Positive velocity increasing. Negative velocity decreasing means negative gradient decreasing, obtuse angle increasing. Obtuse angle increasing. Obtuse angle increasing. Positive velocity increasing means acute angle increasing. How do I draw obtuse angle increasing? Obtuse angle increasing means I want to draw something like this. Then finally velocity 0, obtuse angle increasing. Obtuse angle increasing. Then finally velocity is 0. That means tangent horizontal. Now acute angle increasing. We draw in this way, okay? Graph number 15 also done. 16. We have 5 more, then we'll stop it. We'll draw the remaining 5 and we'll stop it. Then done. Then done. Then we finish to total. Today we finish. Today I will tell you, teach you, if we teach a small thing, converting VT to AT and AT to VT is not difficult. Small thing, same thing. Okay, I'll tell you. Then 15 done. 16. 12 and 16 same, right? 12 and 16 same. Therefore, I don't draw 16 one. We'll draw last 4. 17, 18, 19, 20. 17, 18. If I draw 17. If I draw 17. If I draw 17. 17, what happened? 17, something like this. Right? Something like this. This is our 17. If I convert it. If I convert it. Now what's happening here? Negative velocity increasing. Negative velocity increasing here. Check the y-axis. Check the y-axis. Positive velocity decreasing. Negative velocity increasing means obtuse angle. Obtuse angle. Negative velocity increasing means obtuse angle decreasing. Positive velocity decreasing means acute angle decreasing. Obtuse angle decreasing. How do I draw obtuse angle decreasing? Obtuse angle decreasing. Obtuse angle decreasing. Obtuse angle decreasing. Acute angle decreasing. Acute angle decreasing means something like this. Something like this. (18, 19, 20). We have 3 more graphs. 18, 19, 20. Graph number 18. Graph number 18, 19, 20. 18, something like this. Velocity time graph, want to convert to displacement time graph. Right? Look how we convert this one. Now, here what's happening? Positive velocity increasing, positive velocity increasing. Look here. Both the cases, positive velocity increasing. Positive velocity increasing. This one is also positive velocity increasing, but here positive velocity rapidly increasing. Now, comparing with positive velocity increasing in first part, second part, positive velocity rapidly increasing. Positive velocity increasing means acute angle increasing, but acute angle rapidly increasing. Acute angle, if I say acute angle increasing slowly, acute angle rapidly increasing. Rapidly increasing. That's how this graph finishes. Last two. 19. 19. Something like this. Now look here, y-axis, negative velocity increasing. Negative velocity increasing. Here, negative velocity constant. But the important point is, just think about negative velocity here. Negative velocity here, I say V1. Negative velocity here, I say V2. V1 is larger. Negative velocity here is larger. Negative velocity here is larger than negative velocity here. Now the thing is, larger the negative velocity, understand, larger the negative velocity, smaller the obtuse angle. Write down important point. Large the negative velocity in ST graph. In ST graph, write down. In ST graph, large the negative velocity, smaller the obtuse angle. Okay. Then negative velocity increasing means obtuse angle decreasing. Obtuse angle decreasing. Obtuse angle decreasing. Look here. Obtuse angle decreasing. Obtuse angle decreasing. Negative velocity constant means obtuse angle constant. But now obtuse angle must be larger, right? Because smaller the negative velocity, larger the obtuse angle, right? Smaller the, okay, how do you draw this one? Now, large the obtuse angle. Obtuse angle larger. You got what I'm saying? Now, one can finish from here and I can draw it. If not, one can finish here and draw it. There is no issue. Because we can't get any idea about displacement. The last graph. Okay, graph number 20 is a homework. Look here. Now look here. The graph number 20 is homework. Now look here. Now ST to VT conversion, VT to ST conversion, everything is done. Right? Now you want to learn about VT to AT, AT to VT. Right? Then next week, we can start the last section in motion graph, the calculation section. From the graph, we take data and we do the calculation per section. Next week, we can do it. Next week, we can start vectors also. Now, how do you convert VT to ST? I will teach you how do you convert VT to AT and AT to VT. Then I will do some homework, do them, okay? Now, maximum I will take 5 minutes and I will tell you, then it's finished. Okay, now time is 10:25. 10:30, I'll stop it. Okay. How do you convert? Now understand, if you want to convert, very basic idea. Now you know how to convert ST to VT and VT to ST, you know that. If you want to convert VT to AT, look here. If you want to convert VT to AT, if you want to convert VT to acceleration time graph, look here. Assume, now they give VT graph and they ask you to convert AT graph. Think that VT graph as your ST graph. Think AT graph as your VT graph. Assume in that way and do what I'm saying. Assume. Now think this VT graph as ST graph. Think AT graph as VT graph. It seems like converting ST graph into VT graph. So converting VT graph into AT graph exactly equal to converting VT graph into AT graph exactly equal to converting ST graph into VT graph. Raise your hands. Do you understand what I'm saying? Hereafter, if they have given VT graphs, if you want to convert the AT graph, think VT graphs as your ST graph. Think like that. Think like that and do it. Convert, think VT graph as your ST. Just think in that way and convert ST to VT. If you want to obtain VT to AT, it's exactly equal to converting ST to VT. Raise your hands. How many of you understand what I'm saying? How many of you understand what I'm saying? Raise your hands. Next thing is, suppose if you want to convert AT to VT, if you want to convert AT to VT, AT to VT, that is exactly equal, converting AT to VT, that is exactly equal to think AT as your VT graph. Think, assume, right? Assume A as your V, assume your V as S, then it seems like converting VT to ST. Seems like converting VT to ST, right? That's the logic. If you really, it's a small logic, you can understand. Now what you do, now after now homework, now complete that 20th one also, and in your tute question number, page number 23, third one and fourth one. Third one, convert VT graph into AT graph. Fourth one, converting AT graphs into VT graph. It's very similar thing, okay? Then do until question number 4. Then next week onwards, next week I will tell you about how to do the calculation based on the graphs. That's very easy. And next week we can start vectors also. Then in unit 1, what we missed actually, measuring instrument part is I didn't teach you. The reason is because in December mostly I will start a physical batch in Colombo also. And online, I plan to start a new online batch for this month, but I could not start because I didn't get a positive thing from student side also. But anyhow, after all result comes, I will start a new batch. Then based on all of them, I'm holding that measuring instrument practical part. I'm holding that. I will do it. Don't worry. Other than that, I think in addition, unit 1, measuring instrument, I didn't teach you. Other than that, I taught you everything. Unit 2, everyone start from the vectors, but I didn't start from the vectors. I start from the motion, and because then all students are like to learn. Then I think we finished almost motion graph. The relative motion section is there, but relative motion section I will teach you. But after I taught you vectors, then I'll teach relative motion. Then I think I'm doing everything in the right track. Even we are not slow actually. I think we are some comparing other classes. I think we are going somewhat faster actually. Coming days we will go much faster and we will increase the time duration also. Don't worry, it's an online class. Whatever the time that we want, I can do classes. You have the recording access. Therefore, it's not like a physical class. You don't need to worry that. Yeah, that's what I want to say. Then we'll stop for today and do the homeworks. Redo again and send me as a PDF. Every day I say that. Even though I don't say, but you know that what to do after class finishes, redo them again. It's again redo it. Then you get something. Then when you do tomorrow and when you do today, there's a difference between them. As soon as you know the difference between the tea, the hot tea and the cool tea. There's a big difference between them. If you drink the hot tea as soon as it's prepared, the taste is one. And if you drink the same hot tea after 2-3 hours later, it'll be a cool tea. Then you feel different taste. So therefore, this is also very same thing. If you redo today itself, then you get something bigger than when you do it on tomorrow. Therefore, you decide what is best. You like hot tea or cool tea, and you decide it. We'll stop today, and yeah, we'll stop it. Study with.